Okay. Let me talk a little bit about data camp because there's a bunch of confusion, and I'm also confused because it behaves a little different than what I anticipated. So, I'm being nice to you guys, but I don't want my niceness and the freedom that I'm granting you to be a detriment to your learning. Okay, so I thought that when I go on data camp, how do I sign in? Oh, okay, hang on.
Still in progress.
Okay, yeah, I'm trying to figure out what which courses to assign to you guys. Okay, so in oh, maybe I don't want it. Maybe I don't want this to be broadcast here. Okay, so under assignments and stuff, so when I created like the deadlines and stuff, it was like apparently in some other time zone.
Oh.
And so it ended up like being at 4 a.m. over here, and that was not what I expected. So anyway, I think I figured out this time zone thing, and I don't know how it figures out what's late and what's missed. And apparently,
It's if it's completed by that month.
yeah, and but then, I'm not going to open up my grade book, but apparently, even if somebody is late and they complete it via the thing, it sends back 100% on CCLE. Okay, so basically the deadlines that appear on data camp don't mean anything. All right, and okay, basically, so we'll just give, I guess, a hard deadline and of, I guess, 10th week Friday, and I'll just lock up the grade book. Okay.
Cool.
But all right, this is the thing. Because of that, I know some of you, and I hope not all of you, and I hope not any of you, but I suspect that a few of you would not do anything until 10th week Wednesday, and then in a great state of panic, I don't know, just blitz through 20, I don't know, 15 courses on data camp and things like that. Please don't do that, okay? That's not going to help you learn, okay? You guys signed up for this class because you wanted to learn Python, and then saving it all up to the very end is not going to help you learn. If you just like picking up a foreign language, you really have to expose yourself to the language a little bit each day, okay? You can't just save it up once a week or something right before the quiz or things like that. No one would expect to learn, a foreign language if they only opened up Duolingo once a week, right? So same thing here. Programming is just like learning another language. So I recommend, a little bit each day. I'm still going to keep putting in the things like this, and I'm going to still put in little deadlines on data camp, because I know, at least for some of you, the idea of showing up in the red, even though it means nothing in terms of your points, your personality is not satisfied with showing up in the yellow or red zone. So that will be enough to kind of push you along, even though it doesn't count against you on the grade book. And there's like tons of courses, so I'm gonna try to limit myself to doing no more than 2 in a week. And but I guess I can link like optional ones that. It says 8 hours, but I don't think the things take the full 4 hours each, right? It's, if you take your time and you take notes, then yes, it will take a while. But my impression is that those time estimates are generous. Okay, so anyway, that's how it's gonna go. And I don't know, are there any questions on this? So So basically, if you miss the first deadlines and stuff, it doesn't matter. You're just gonna get a little yellow or red mark over here. But in the gradebook, if you complete it, you'll get 100%. Just make sure you click the link through it and let Data Camps transfer the grades back to our gradebook. Okay. All right. Let's. Oh my goodness. Okay. We are out of time. Okay. We are going to this week look at pandas. Okay. Yeah. And so basically, pandas are built on top of NumPy. So NumPy takes in data is kind of like the atomic vector in R in that each NumPy array only allows data of the same type. Okay, lists can be heterogeneous. The NumPy arrays have to be homogeneous in terms of the data type, and then pandas kind of links these things together to get a data frame. So each column will have one data type, but you can have several columns of different data types, and then you have basically a data frame. Very similar to what we have in R. Okay? And each column is known as a series object, a pandas series object, and it will consist of the data values, and then there's also an optional index, which is effectively the row names. Okay, so when you create a series, you're putting in the values, and then you're also providing some row names, and this allows it to, by having the index, the row names, it gives instructions for pandas to be able to kind of merge data sets and do manipulations like that. Okay. Again, just like NumPy, we import NumPy and we import pandas, and we import it as NP and pandas as PD. This is kind of the convention, and if you do something different, you're going to confuse other people. Okay, so so this is how we do it. We create the series just by providing the series, basically a list, or a NumPy array, whatever, and you go pd.series, and you throw that in there, and then if you don't provide the index, it will default to using its normal indexing modes of starting at 0 and counting from there. Okay, you can and if you ask what's the type on this object that we created, it's going to say it's a pandas series. Okay, and then when you print it out, it comes out in table form, and yeah, that's that. Okay, and then for a series, there's an attribute called values, so you can do data.values, and this will be a NumPy array. Right, so you can pull out the values there, and it will be a NumPy array and have all the behaviors of a NumPy array. Okay, and so Python being the kind of the object-oriented language, all of these things are certain object types, and every time you have a certain object type, it will have all of the methods and behaviors and attributes that that object has, right? So if I did shape of this thing, what would it say?
Oh. 4, comma.
Yeah, it'd be
Parentheses.
parentheses 4 comma, right? So it's one-dimensional type of thing. All right, and then the index, you get a pandas index type. Okay, so the pandas index type is what we have here. Okay, so this is a range index. Okay, and then just like the other Python objects, okay, you can subset. So here, taking data, if I ask for the object at index 1, it's going to give me back 0.5. Okay, and if we ask for the type, it's not a pandas object, it's that object itself, and which will be a floating point number.
Okay. 64 is a bit.
Yeah, float 64 is double precision. It's the same thing as type double in R. There's also float 32, which R does not have, but it would be single precision floating point. There's not really an advantage to using single floats, float 32s, unless you're like working on a machine with like really limited memory or something, but everybody uses float 60. I shouldn't say everybody, but that's what we use. Okay. Just like other things, you can slice it. So data 1:3 will give you rows 1 and 2, things like that. Okay, and then when you ask for the type on this, if you slice out multiple rows, then it will be a series, Pandas series, just like that. And then you can also do fancy indexing. So here I'm providing it the array 102, and I'm subsetting it based on that, and it pulls out those rows in that order. Okay, you can instead of using the default index values, you can provide a list with the index names. And so here I'm using A, B, C, D for the index names. Now the Pandas series looks like this. Okay, and then and you can continue to subset the series using normal index notation. You can also use the index name. Okay, so here I'm going to say pull out the value associated with A, and then and you can also I don't know if slice is the correct word here, but you can extract it using the colon, and it'll pull out A through C. But notice when you're using the names, it includes the endpoint there. So here I've got A:C, and it pulls out A, B, and C. Whereas if I go back and use the numbers and use the index value 0:2, the slicing behavior is unchanged. Okay. You can also create a series from a Python dictionary. I know I did not cover dictionaries in lecture, but it was covered in like your data camp intro or intermediate or something, right? It's covered in one of the data camp things. Basically, a dictionary is a series of kind of key value pairs. Okay, so you give it. So here I took the characters from the Archie comics and now in the Riverdale TV series. But here we take their names and these are the heights of the people. I was just trying to figure out what's a good numeric value I can do, and the heights are readily available on the internet. So
the heights of fictional characters.
The heights of the actors portraying fictional characters.
Oh,
okay, so all right. Okay, so anyway, we create a dictionary here, and then we can take the dictionary and throw that into a Pandas series, and that becomes a series. Okay, so here, so now we have the series, and then if you ask what are the indices of this series, now we have a list of names. Okay, and so this is the index. If you ask what's the type, the dictionary is a type dictionary, whereas the series is a Pandas series. So that should be no surprise. Okay, here I'm creating another dictionary. Okay, and when you throw the dictionary into a series, it orders the series. So dictionaries are inherently unordered, right? There's no order to them. Pandas series do get an order, and so the default ordering is going to be alphabetical. Okay, so here it goes, A, B, V, J, C, and here goes A, B, C, J, B. So, and likewise, if I change up the order of the dictionary, it doesn't matter. When you throw it into the series, it orders them. Okay. So here I've got a dictionary with names, and so these are the fictional characters and the first names of the actors who play them. And then so to create a data frame, you create a dictionary of series. Okay, so you say you give it the column name, effectively. Okay, here is the column name and the series that contains the that column's values. And then here's the other column name, and you provide it the series there. So this is a dictionary of series objects, and the names that you provide, or the keys that you provide in the dictionary, become the column names. And then the row names are preserved from, or the index names become the row names in the data frame. So here, you provide it like this, okay? And the type of this is the Pandas data frame object. Okay. Over here, you can also create a data frame by throwing a list of dictionaries. Okay. So here, this up here is a dictionary of series. This over here is a list of dictionaries. Okay. And so here, each dictionary has the same kind of keys. All right, so here it says A0, B0, and then here the next dictionary in the list is A1, B2, and then the next dictionary in the list is A2, B5. Okay, so here is a list of dictionaries. When I throw that into the data frame, and here I'm providing it an optional list of the indices of the index going 1, 2, 3, rather than the normal 0, rather than leaving it at the default. And you can see that it's taken each kind of key value and thrown them into the columns here. Okay, here let me just show what would happen. We might run out of time. Okay, so let's say here I'm gonna do one that's different though. Okay, so I got AB, AB, and AC here. Okay, and then I'm gonna throw this into a data frame. So I'm providing the data frame the list of dictionaries. Okay, and so what this will do is it takes kind of each key value pair in the dictionary, and it does its best to match them up. Okay, so it says, oh, here I got AB and AB, and but for this object I don't have a B, so we get a missing and a nan, and then over here none of them have C, so we get nans here. Do you see what's happening there? Okay, so here I've got it's a list of 3 dictionaries with values for A and B, value for A, a value for B, a value for A, and a value for C. And so when you throw that into the data frame, it matches the A's with the A's and the B's with the B's and the C's with the C's, but they don't all match, so it throws in nans for the missing things.
And the A's are all integers?
What's that?
Like the A column's all integers.
Yeah, the A's will be integers.
B
yeah.
and C are floats.
Because B, this is a good observation, because nan objects are always floats. Okay, and so it upcasts the what originally were integers get upcast to floats in order to accommodate the nan.
I see.
Okay. Okay. Now I'm curious, because I don't know what's going to happen. What if one of these was a string? Okay, let's just see what happens, because I want to know. I get it. I'll use that as a string, I guess.
Yeah.
All right, I don't know. Okay, I'll have to investigate. Okay, just like you can also create a NumPy array. Okay, so here I created a NumPy array, and then and I'm throwing the NumPy array into the data frame function, and here I'm providing a list of names for the column names and a list of names for the index, okay, or a list of strings to give the row names the index. Okay, what's that? Okay, and then we might run out of time here, but with subsetting, so here I've got the data frame with column actor and column height, and we can ask, what are the keys in this? So again, keep in mind, you can think of the data frame as a dictionary of series objects that line up here. And so when we ask for the keys, it tells us the keys that are available are actor and height. You can say, all right, what is the actor column? And it goes and it pulls out the actor column, that series. Okay. Another thing, you can also, because they are these objects, you can use the dot notation and extract out basically the actor attribute from here, and it pulls out the exact same thing. So you can kind of subset and extract out the column this way, or with the dot notation, and then once you have that, they behave just like regular old Pandas series. Okay. It being a two-dimensional thing, there are methods like transpose, and it transposes it like this. If you want to pull out a certain row, you use the dot lope for location of the Pandas object, and it will pull out that row. And then just kind of like pulling out certain things, you can use ilope, which will be the index location, and you can kind of provide it either one or multiple coordinates to pull out the values at those coordinates. Okay, we'll end here for today. We'll see you guys on Wednesday. We'll cover more Pandas stuff. Please check it out in Data Camp as well.